Well, Professor Clements with you. I'm starting the PowerPoint here for the material on a little bit on time of rising for stars first. And then the main thing will be phases of the moon. So the Earth is orbiting the sun. Let's imagine standing here, the sun on the meridian at noon, and we're going to let the Earth move around in its orbit. This is a little bit exaggerated here, but out to position 3 would be the next time that the sun would be on our meridian. So our Earth is spinning around, of course carries the observer from noon to midnight, back over here, and back to noon again. And the Earth is going to spin in 24 hours, pretty close, to give us that noon to noon experience. So let's consider about a star being on the meridian. A star being on the meridian. The stars are very much further away than the sun, and as the Earth spins, the star will get back on the meridian before the sun is on the meridian. The stars are always off to the left here, and the Earth spinning is going to bring that star to the meridian from our point of view in about 4 minutes less time, it turns out, than when the sun is on the meridian again. So our stars are kind of advancing across the sky. If we use the sun as a reference, the stars are 4 minutes early each day across the meridian, and that also applies to their rising and setting. The stars rise 4 minutes earlier from day to day. They get to the meridian 4 minutes earlier according to our watch that's based on the sun. And the stars get to the west horizon 4 minutes earlier each day. So this is due to the Earth orbiting the sun. We have a little bit discussion on time zones. It's convenient to have the sun on the meridian around noon. Well, if the Earth had just one time zone, then some people, the sun would be on the meridian at midnight. Some people, the sun would be on the meridian at 6 a.m. So we have the time zones. They were established in the United States when the railroad went across, and telegraph communication need to be kind of coordinated, and train schedules need to be coordinated. So we have 4 time zones that span the United States: Eastern, Central, Mountain, and Pacific. You don't need to memorize these time zones, but you should know there are 24 time zones going around the Earth, and it helps us have our sun near the meridian at noon. Okay, phases of the moon. You've all seen the moon: crescent moon, full moon, different phases. The phase of the moon depends on where the moon is in the sky compared to where the sun is. So we're going to take a look at some diagrams that show us this, but from our point of view, we see the moon going around the Earth. The moon reflects sunlight. The moon does not shine on its own, so it's not glowing, it's reflecting. And that position of reflection is what gives us the phases. The moon does have considerable size compared to the Earth, about 25% of the size of the Earth, so it's got a big area that can reflect sunlight. But it is quite a bit distant from us, 60 times the radius of the Earth. So here's a scale photograph that is correct. So Earth here and moon out here. This is real. As we look at the sky, the moon appears bigger than this, but this is the actual configuration. So Earth and the moon is reflecting sunlight to give us its phases. Just a kind of scale model. So you're used to seeing a basketball. If the Earth was represented by a basketball, then the moon would be a tennis ball and about 23.5 feet away. So about 8 big steps away. So you keep that in mind perhaps. We have a near side of the moon where we see these large dark areas, the Maria, and we'll talk more about those when we talk about the moon. And the moon is rotating, it's spinning as it orbits the Earth. It spins once every 27.3 days. As we watch the moon go around the Earth, we see it go around the Earth in 27.3 days. It's not a coincidence. There's a physical reason for this. We'll talk more about it when we discuss the moon. But the moon does one orbit around the Earth in 27.3 days, from our point of view. The moon spins once on its axis in 27.3 days. Those two numbers lead to the fact that the same side of the moon always faces the Earth. So we have one side of view from the Earth. We see the near side of the moon. The other side of the moon, in this picture, it is dark, but it's not always dark. It might be facing the sun. We'll see that in some of our diagrams. So we talk about near side, we talk about far side. We always see the near side because the moon spins once for one orbit around the Earth. So here are some phases that you could view in the early evening when we're just starting to see the crescent moon, so in the southwest. First quarter, the moon would be on our meridian at sunset. Waxing gibbous, and then full moon, and then the waning phases are when we're getting less light in view on the sun, and these you see after midnight. They're in this part of the sky that's the eastern sky. So what's the process of causing the phases? So sunlight comes onto the Earth and also comes onto the moon. If the moon is basically between the Earth and the sun, then that sunlight is going to illuminate the side of the moon, the far side that we don't see from Earth. If the Earth is in between the sun and the moon, so the moon more distant, now sunlight illuminates the disk of the moon on the near side, and we have full moon. So we'll do some more of this, more diagrams. So sun off to the left, great distance away. So this is case 1, that's new moon. We have here the white area showing where sunlight is. The green hashed area is the far side of the moon that we don't see. So we see new moon. The moon's surface is dark. It's difficult to see the moon. So moon goes around its orbit just a little bit. Notice that the one half of the moon is receiving sunlight. And now as you're on the Earth and looking at the moon, you see the half of the moon that's near to the Earth. We see a little wedge of light here. We see a crescent moon. In configuration 3, again, half the moon is always bright. If you imagine yourself on the Earth here looking at the moon, the right portion of the moon is bright and the left side is dark. This is the quarter moon. I just noticed here these diagrams the numbers are shifted just a little bit. Here's 1, here's 2, here's 3. This is the quarter moon, first quarter moon. And then we get into the waxing gibbous as the light is getting more and more across the surface from night to night. Full moon here, and then waning gibbous, third quarter moon. The moon is 3/4 of the way around its orbit, starting at new moon, so third quarter moon here, and the waning crescent moon. Here is sort of night by night. A person took photographs of the moon and then stitched together into a movie. And you can see I'll start here, new moon, crescent, quarter, gibbous, full, gibbous, quarter, crescent. It goes a little bit fast, but when the moon's brightness is increasing, that's waxing, so waxing there. And when it's decreasing, waning, so that's the waning. Waxing, getting brighter, waning, getting dimmer. You have crescent, quarter, gibbous, full, gibbous, quarter, crescent, new. So you can play with that sometime. Another diagram here illustrating Earth and Moon. The sizes are not correct, but they need to make a little big so you can see where the bright part of the moon was. Again, if we go here to this quarter moon, this half of the moon's getting sunlight, this half is dark, and observing from the Earth, we see the right side of the moon being bright. It's a portion up here. The left side of the moon, from our point of view, being dark. That's the quarter moon. then gibbous, then full, gibbous again, back over here, third quarter, 3/4 of the way around its orbit, and then crescent again, and then new. So those are the phases of the moon. The phase depends on where the moon is located with reference to the sun. If the moon is on the same side of the earth as the sun, it's more or less in line, not perfectly in line, but more or less. That's going to be our new moon. And if the moon is on the opposite side of the earth from the sun, that'll be our full moon. If the moon is just a little bit past new moon, that'll be our crescent. If the moon is a quarter of its orbit, that's going to be our quarter moon, first quarter moon. Then gibbous, full moon, gibbous, third quarter here, and waning crescent as we come back to new moon. And again, we always see the same craters on the moon from the point of view of the Earth, because the moon spins once on its axis for one orbit. It's slowly spinning, one spin in 27.3 days. The Earth is spinning once every 24 hours, but the moon spins more slowly, once every 27.3 days. That matches the time for one orbit from our point of view on the Earth. So we always see the same side of the moon. You ought to keep reading about that, write a few questions down, and ask them. So we'll end there and let you continue reading.